not that difficult once you get the hang of it, the tricks of the trade. Just say commutative means to change the order, and associative means to change the grouping, and distributive multiply the outside by the in. With identity properties, you get the same answer by multiplying by 1 or adding 0. Multiplicative inverse means you take a number and flip it. You multiply across the answers always 1. And commutative means you change the order, and associative means you change the grouping, and distributive multiply the outside by the in, the in.
Okay, so you just listened to a song about all of our properties and a couple extra actually. So I kind of want you to block out that whole distributive thing, and I want you to block out anything related to multiplication, because we're only focusing on addition and subtraction in chapter 2. So you need to focus on commutative, associative, and identity. And then we'll also talk about subtraction rules when we do our notes. But really quick, I wanted to show you some hand motions that go along with these properties that we use a lot in class, and hopefully they'll help kind of sink in what these properties mean. So commutative property means we change the order. So we're constantly switching sides. Okay, sometimes the numbers are here, sometimes they're flip-flopped, but no matter which order we add numbers in, we'll always get the same answer. So commutative property changes the order. Associative property changes the grouping. So I want you to make parentheses with your hands and go like this. They change the groupings. So you can remember associative property always has parentheses in it because different numbers are grouped whenever they're adding, but no matter which grouping you have, you're always going to get the same answer again. And the answer to an addition problem is a sum. So whenever we are talking about identity property, you're going to need something that shows a reflection. I have sunglasses. I can kind of see myself. I wish I had a mirror. But if you have a mirror, that's awesome, because when you look at yourself in a mirror or something that's reflective, you see yourself. And whenever we add to 0, that number, whatever we're adding, it could be a number in the millions, it could be 5. No matter what number we're using, whenever we add 0 to it, that number sees itself again on the other side of the equal sign. 5 plus 0 is 5. 3 million plus 0 is 3 million. So that's the identity property, being able to see yourself on the other side of the equal sign. Okay, go ahead and grab your math notebooks and let's take a few notes. Okay, here are our notes for chapter 2. Since we're starting a new chapter, I want at the top for you to say what chapter we're on and the title. Chapter 2 is add and subtract whole numbers. So you're thinking, well, adding and subtracting, that isn't all that difficult. But as we move through the grades, 4th grade is a time where we just kind of make the numbers bigger and the problem's more difficult. So you may know how to add and subtract numbers that are smaller, but we're going to focus on those bigger numbers and what that means. And today we're obviously focusing on properties. Properties are useful because they help us to understand why we can do certain things with numbers. So let's start by writing down what the commutative property is. Make sure you spell it correctly because nobody ever does. Commutative properties. So there's going to be quite a few notes today just because we're writing down what all these properties mean, and we'll be including examples as well. So the commutative property, and we're talking about addition, so if you want to put like in a little addition symbol in parentheses there. But the commutative property of addition says that numbers can be added in any order. The sum is always the same. That is the whole point of this lesson, is no matter what property you're using, the sum is always the same. So that's super important. For example, though, let's write down an example of what this might look like. So the commutative property we could do, let's do an easy example. Let's do 5 plus 3. Okay, 5 plus 3 equals 8. But if I want to have the smaller number first, I could say 3 plus 5. And no matter which order I have this in, my answer is always going to be 8. So whether I do 5 and add 3 to 5, or whether I start with 3 and add 5 to 3, my answer is 8. So that is the commutative property. Okay, the associative property is next. And again, we're only working with addition. These properties will come back later when we work with multiplication, but right now we're only working with addition properties. And then there will be a couple subtraction rules as well. For the associative property, numbers can be grouped differently when adding the sum is the same. Oh, look at that. The sum is the same. The sum is the same. See that? So no matter which property we're using, a lot of times associative property is used whenever we have more than two numbers that we're adding, because then it's like, well, what order do I want to add in? And whenever I add in a different order than what the problem is written in, you have to kind of group those numbers together. So let's say we have the problem 10 plus 5 plus 4. Okay, so whenever I look at this, I can either do 10 plus 5 or I could do 5 plus 4. Let's say I want to do 5 plus 4 first. The way that I show that I want to do it first is by adding in parentheses to my problem. So this would then go to 10 plus 9. 10 plus 9 is 19. If I change the grouping, I keep it 10 plus 5 plus 4, so I don't mix up my properties, because if I change the order of these numbers, then I'm also using the commutative property. Right now, I just want to see what is the associative property, so that's why I'm keeping the numbers in the same order. But now I'm going to group two different numbers. So instead of grouping 5 and 4, I'm going to group 10 and 5 together. So that means I have to add these numbers first. 10 plus 5 is 15. And then I will add 4 afterwards, which still equals 19. So again, with the associative property, the sum is the same. Remember, sum is the answer to an addition problem. If you need to write that down, please do. The final addition property is identity property of addition. Okay, so the identity property of addition states that the sum of any number and 0 is that number. So that means when I add 0 to any number, I'm going to get that number that I'm adding to 0 as my answer. So I could pick literally any number that I wanted to right now, and 524 for some reason pops into my mind. And when I add 0 to that, the number that comes out on the other side is 524. Nothing happened to it. 0 shows the identity of this addend. So remember, addend are the numbers that we add together, and sum is the answer. So let's really quick label that what we're adding together, those numbers are called addends, and our answer is called a sum. Okay, you might notice in your book that these are all highlighted in yellow, meaning that they are vocabulary terms that we need to know for this lesson, but there's also another vocabulary term that's not a property. It's just a term. So I'm going to kind of split my page up just a little bit, and I'm going to write down my next vocabulary term, which is called the unknown. Sometimes in a problem, you will have to figure out a number that's missing in a number sentence. You might have seen things like this, where we have box plus 4 equals 7. Okay, this right here is a number that we're missing. It is the unknown. So unknown means, if it says find the unknown, that means find the missing number. And in this case, our missing number would be 3, because 3 plus 4 equals 7. Okay, so I'm using pretty easy numbers, but I always like to use easy numbers in notes because it helps make new concepts seem less difficult. Okay, now we're going to move on again. I'm going to kind of split this up again to subtraction rules. And you don't necessarily need, this is why you use pencil. You don't necessarily need to know a certain name for the subtraction rules. They're just called subtraction rules. So any time that you see a problem for a property lesson like today, and it is a subtraction problem, you don't have to say, oh, it's this type of subtraction rule. Basically, all you have to say is that it's showing a subtraction rule. So I just want to show you a couple examples of what some subtraction rules are. Okay, so subtraction rules, kind of like the identity property, anytime that you subtract 0 from a number, you're going to get that same number as your answer. Okay, so it's kind of like an identity rule with subtraction. But that's one subtraction rule. Another subtraction rule is if I were to take 11 and subtract 11 from it, my answer is 0. So when I take the full number away from itself, I'm left with nothing. Now this might seem pretty basic knowledge to you. It's just put into a rule because it happens every single time, no matter which number that you use. So now it's like a rule in math. So anytime today that you are working on properties and rules and you see a problem that uses subtraction, don't think about any of these terms up above. You will just write subtraction rules as your answer for that. And there's no really specific names for them. They're just called subtraction rules. Okay. These are our notes for this lesson. Remember, commutative changes the order. Associative has parentheses. And identity, you see yourself. So, good luck on today's worksheet, and let us know if you have any questions.